Let's begin the journey by going back to the very first time when astronomical observations were made. Babylonia was one of the earliest civilizations on this planet. The earliest records show that Babylonians had started collecting information of planets and stars between 2000 BC to 1600 BC. To understand how the Babylonians used science, one must first understand how they viewed science. Babylonian science was extremely advanced in many ways, especially when one considers the science of contemporary civilizations, but it was devoid of any abstract reasoning such as theorems or proofs. Essentially, Babylonia's science was all practical and always used for the good of the state. For instance, advanced math was used to divide farmable land into plots that resulted in not only standard rectangular parcels but also triangle and even polygon plots of land. The Babylonians were able to create calendars that were more accurate than those produced by their contemporaries because their calendrical observations were aided by advances in astronomy and maths. There is a common misconception among many people in the modern world that scientific thought began with the ancient Greeks. But an examination reveals that true science was being practiced centuries earlier in Mesopotamian city of Babylon. Moving forward, other very bleak and not so correct observations were made by many philosophers from India and Greece by the 4th century BC. Indian scientists were able to contribute a lot to science later on. The Greeks tried very well to advance sciences and did succeed to some point. But even their most famous philosopher, Aristotle, in the 4th century BC, thought that the universe was geocentric. That means the earth was at the center of the universe. But he rightly believed that the earth was spherical and put forward many arguments on this topic. Let's talk a bit more about Aristotelian physics. We know that Aristotle was one of the best philosophers history has ever witnessed. He tried to explain the universe in his own ways, which did not turn out to be correct as we know today, but at that time, without any technology involved, whatever thoughts he had are worth having a look at. Aristotle divided his universe into terrestrial spheres, which were corruptible and where humans lived. Aristotle believed that 4 classical elements make up everything in the terrestrial spheres: earth, air, fire, and water. He also held that the heavens are made up of special weightless and incorruptible 5th element called ether. Ether literally means 5th being. So now we know who gave birth to the concept of ether. Aristotle considered heavy substances such as iron and other metals to consist primarily of the element earth with a smaller amount of the other 3 terrestrial elements. The Aristotelian explanation of gravity is that all bodies moving towards their natural place. For the elements earth and water, the place is the center of the universe. The natural place of water is concentric shell around earth because earth is heavier, it sinks in water. The natural place for air is likewise a concentric shell surrounding that of water. Bubbles rise in water. Finally, the natural place for fire is higher than that of air, but below the innermost celestial sphere carrying the moon. Terrestrial objects rise or fall to a greater or lesser extent according to the ratio of the 4 elements of which they are composed. For example, earth, the heaviest element, and water fall towards the center of the cosmos. Hence, the earth and for the most part its oceans will have already come to rest there. At the opposite extreme, the lightest elements, air and especially fire, rise up and away from the center. The elements are not proper substances in Aristotelian theory. Instead, they are abstractions used to explain the varying natures and behaviors of actual materials in terms of ratios between them. The reign of Aristotelian physics, the earliest known speculative theory of physics, lasted almost 2 millennia. After the work of many pioneers such as Copernicus, Galileo, and Newton, it became generally accepted that Aristotelian physics was neither correct nor viable. Despite this, it survived as a scholastic pursuit well into the 17th century until universities amended their curriculum. There were many other theories which tried to put things in place but were unable to do so until the scientific revolution, about which we will discuss in the next video. Another interesting story from the earliest days of scientific discoveries is about the radius of the Earth. By around 500 BC, most of the Greeks believed that the Earth was round, but they could not figure out its size. Around this time, Greek philosophers had begun to believe that the world could be explained by natural processes rather than invoking the gods. The early astronomers began making physical measurements in part to better predict the seasons. The first person to determine the size of Earth was Eratosthenes of Cyrene, who produced a surprisingly good measurement using a simple scheme that combined geometrical calculations with physical observations. Eratosthenes had heard from travelers about a well in Syene, nowadays in Egypt, with an interesting property. At noon on the summer solstice, which occurs about June 21st every year, the sun illuminated the entire bottom of this well without casting any shadows, indicating that the sun was directly overhead. Eratosthenes then measured the angle of the shadow casted by a stick at noon on the summer solstice in Alexandria and found it made an angle of about 7.2 degrees, or about 1/50th of a complete circle. He realized that if he could find the distance between the two cities, then he could easily find the circumference of the Earth. Suppose this is Syene, and you put a stick here so the rays produce no shadows, whereas at Alexandria it produces a shadow at an angle of 7.2 degree, or 1/50th of a circle. So you know that the angle between these two places is of 7.2 degrees from the center of the Earth, or 1/50th of the whole angle. So this distance will also be equal to 1/50th of the total circumference of the Earth. So if you multiply the distance between the two cities, you should get the circumference of the Earth. But in those days, it was extremely difficult to determine distance with any accuracy. Some distances between cities were measured by the time it took a camel to travel from one city to the other. But camels have a tendency to wander and to walk at varying speeds. So Eratosthenes hired professional surveyors trained to walk with equal length steps. He then used this to calculate the circumference of Earth to be about 24,000 miles. The Earth is now known to measure about 24,900 miles around the equator, slightly less around the poles, so he was quite accurate. Eratosthenes had made the assumption that the sun was far away, thus its rays had to be parallel, that Alexandria is due north of Syene, and that Syene is exactly on the Tropic of Cancer. While not exactly correct, these assumptions are good enough to make a quite accurate measurement using his methods. His basic method is sound and even used by school children around the world today. This is how the Greeks and other philosophers used to think and work so accurately, and we are talking about 500 BC when there was no advanced technology like today. This was just a very short summary about pre-scientific or ancient discoveries. Philosophers from around the world contributed to the development. The main discoveries and the most useful ones were done later in the medieval period. A lot changed after Galileo looked up at the sky with a self-made telescope, and this changed the scientific world drastically. In the next video, we'll talk about how the proof of heliocentrism combined by Galileo's discoveries and Kepler's law completely changed the way people imagined the universe to be.